It's early 2026 and we already have robots dancing among us, learning to box and even cook. But here is a robot that is built to work for the construction industry.
Indian real estate is estimated to reach $1 trillion in size, but we don't have enough people that can take it there. So our robot can do same work equivalent of what 10 people can do.
The general thought was that robotics has to tackle something which is repetitive, which is mundane, which is boring, and which is also hazardous to health. Construction site is a complete new beast. Everything that we thought would go wrong went wrong.
Today we are here at Pace Robotics, a company in Bangalore that builds modular robots for the construction industry. In this video, we'll get in to understand what it takes to build a robotics company in India, the technical challenges, market adoption, and much more. This is Ashwin from Circuit Digest, and welcome back to another video of India Techno. Before we get started, let me quickly introduce the sponsors for this video, DigiKey. DigiKey is a global leader in cutting-edge commerce distribution of electronic components and automation products worldwide. They provide more than 17 million components from over 3,000 manufacturers with products in stock available for immediate shipment. Also, with their fast shipping and excellent customer support, you can always trust that your products will arrive on time and in top condition. So do remember to check out DigiKey for your next project. Now, to understand more about Pace Robotics and to see their robot in action, we are here in a construction site, and to show us around, we have Srinivas here, who is the co-founder and CEO of Pace Robotics. So let's hear from him. So Srinivas, thank you so much for joining us today.
Thank you for the opportunity.
So Srinivas, can you explain what Pace Robotics is about and what is this robot doing here and what is the problem that you're trying to solve with Pace Robotics?
Right. So Pace Robotics is a construction robotics startup. We are making the building construction process faster, smarter, and more efficient.
Okay.
Through modular multitasking robots. So this is our first product. We call it the Centa Painter. It's a robot for paint, putty, and sanding applications in the interiors of buildings for both wall and ceiling. So construction, as we are all aware, is a very labor-intensive process. And over the years, labor shortage has become a major problem in construction, and specifically skilled labor. And today it is estimated that only 50% of skilled labor is available. And in the next 5 years, between now and 2030, the Indian real estate is estimated to reach $1 trillion in size. But we don't have enough people that can take it there. Okay. So it is inevitable that we need to figure out ways of doing more with how many people we have. So that is where robotics or automation comes in. And that is what we have also been trying to do, where how can we use the existing labor strength to do more work. So our robot can do same work equivalent of what 10 people can do. Or in other words, can take the productivity up 10 times compared to what is the manual productivity currently.
Perfect. So we are standing here at a construction site right next to your gigantic robot. I think it's as tall as me. I'm very eager to see it in operation. But before we do that, can you paint us a picture? Like, what do we have here? I can see a sander here, but what does the machine actually do?
So sanding is it's a grinding operation where the level correction of the wall is done. So the entire finishing process, if I can explain, starts with application of putty. Once putty, it's a paste-like material. Once putty is applied, we do the sanding, which gives us a smooth and perfectly level surface. And on that, we apply the paint. So how we do is both the putty and paint application. This is a spray-based application. The robot just sprays the material on the wall uniformly. Okay. And sanding is an application where it is taking off the material and giving it a smooth and level surface. So currently what you have here is a sanding tool. Okay. It's a rotary sander. It is also connected to a vacuum which sucks out the dust. So what we are doing here is a fully dust-free sanding. Okay. Then there are various sensors on board which will ensure the robot understands where it stands. Robo can see where the wall is, align itself parallel to the wall. It can also see if there is a door and window opening and avoid spraying or sanding in that area. And there are also sensors on board the sander itself, which can understand the contour of the wall. Okay. So it can tell you, it can identify that wall is uneven, and it can correct it and give you a plain level surface.
Okay.
So currently the robot is set for a sanding operation.
Okay. So from what I can understand, just by quick look, is that we have a sander over here, but you also mentioned that it would spray putty and also
Right.
do painting, right?
Right.
How would that happen on this machine?
So when we are spraying this particular module that you see here, this will be taken out.
Okay.
And there will be a nozzle that will be connected here.
Okay.
And there would be a hose that is connected to the nozzle that goes and sits on a pump.
Okay.
The pump is stationary while the robot keeps moving. And the same hose is used and the pump is used when we do the paint application or a primer application as well.
Okay. So we are going to place this robot against a wall and
Right.
turn it on. And what can we expect it to do?
So how we start the operation is there is a joystick with which we keep it next to a wall. When I say next to it, in the vicinity of a wall within 1 meter from the wall where we have to do the work.
Okay.
The robot then does the finer adjustment. It aligns itself parallel to the wall. And once it has aligned, it starts the work. And as it works, it moves from one end of a wall to the other end fully autonomously. And during this, it can align itself parallel to wall. If it loses parallelity, it corrects itself, comes back. And at the end of a wall, we again use a joystick and turn it to the next wall. This is how the wall operations happen.
Okay.
The robot also does the same work on the ceiling as well. At that point, we have to turn this sander upwards towards the ceiling. And when we are doing the ceiling, the robot is fully autonomous within the room. So you leave this inside a room and just move out. Robot completes the ceiling and comes out. Actuators and enough degree of freedom to reach any part of wall, floor, and ceiling. So right now it is at an operation where it is just about to start. So once it starts, it moves up, it reaches the ceiling,
Okay.
and then completes the entire wall. And same way when we are doing the ceiling also, it can reach the ceiling.
Now we have seen how the robot works, but to understand the technology behind it and how all of this comes together and works together, we have Mr. Ayushmoy here, who is the founder and head of product and technology for Pace Robotics. So Ayush, thank you so much for joining us today. So we have already seen this robot in action, and it was inspiring to see how it is actually getting the work done in a construction field. So can you tell us what is happening behind the tech? Like, we can see the robot here, but what is driving everything together here?
Yeah, so I mean, mechanically speaking, there are these various degrees of freedom that allow, as I mean, you would have seen sanding happening, and that comes through multiple degrees of freedom that the robot has through various actuators. There are servo motors driving those actuators. There is a controller. I mean, there are multiple controllers which take care of real-time controls as well as fetching data from the various sensors. And then there's an NVIDIA-based processor which takes care of the higher level stuff like your perception, SLAM, path planning, etc.
Okay, so let's start from the mechanical perspective. So this robot, as I can see, the skin of it is all sheet metal, but under it there is a rigid body. So how much of custom parts you would have to build to put all of this together?
I mean, I would say the design is completely proprietary. And of course, you start with standard elements like your motion elements, like your ball screws and guides and belts and gears and things like that. But then of course, everything, the way it's been put together is completely proprietary, one of its kind, and also a lot of the rigid structures as well as the parts that, I mean, the clamps and the structures that hold everything together, they have been designed in-house, analyzed, etc., etc.
Right. So what all sensor readings are being read from the robot? Like, as I can see, we have proximity sensors, a camera, and even a LiDAR. But what are these sensors doing, and how is it helping for the robot to actually function in the field?
Yeah, so I mean, the sensors are trying to build a kind of a map of the environment, also trying to help the robot kind of understand where the wall is with respect to the robot, how it's aligned to the wall, the work surface. Also, I mean, again, the sensors also help with identify obstacles such as I mean, anything that can be on the wall surface or on the ceiling surface, as well as openings such as doors, windows, etc. So yeah, it comes through a fusion of data from multiple sensors.
Okay. You just mentioned that there are multiple controllers taking care of different segments of the robot. If you have to split it into a subsystem, can you tell us what is being handled by a processor and what is being driven at a controller level?
So the controllers are mainly taking care of, I mean, data processing from all your sensors. Also, like kind of taking over the motor controls. The processor is more to do with your algorithms. So in your all of your computer vision algorithms, all of your SLAM related stuff, and then also your motion related stuff. So that is being taken care by the processor.
Okay. So is it fair to understand that there is some kind of sensor fusion happening in the background along with the camera's feed and the LiDAR feed?
Yes, definitely.
Can you dive in a bit more on what are you doing with this NVIDIA microprocessor and how is it helping for the robot to function safely in a construction area?
So the NVIDIA processor is again like it takes feed from our LiDAR, from our camera, and then builds out a local map of the room. It then kind of helps us localize the robot and also understand. I mean, it helps us also understand what is there on the wall or on the work surface. So, are there openings? Are there projections? So that way, helps us keep the robot safe when it's working. And also, it helps us like create. I mean, in the case of ceiling, for example, the robot's fully autonomous. So it helps us define now what is going to be the best path of motion so that we get the best coverage as well as maintain, the highest productivity that is possible.
Okay. If you have to give us a number on how many sensory inputs are there and how many actuators are there on the output side, can you point it out and tell us what is what?
A lot of this is, proprietary stuff, but just to give you an idea, we would have 20 plus sensors on this robot.
Okay.
And then 7 plus actuators, and various kinds of sensors. Like there's everything from force sensors to, as I said, LiDAR, camera, proximity sensors, inductive sensors, etc., etc.
Okay, perfect. So Ayush, from what we have discussed so far, I can understand that the robot has so many components that has all come together. For example, we have sensors, we have motors, motor drivers, microprocessors, a lot of industrial connectors I can see here. So how was your experience in putting all this together, finding the right parts and putting all this together? How was your journey in sourcing parts for this robot?
Yeah, that was actually one of the things which took us a lot of time to identify the right parts, source them quickly, see whether they work for us or not, and then kind of then moving more towards your production. So, platforms like DigiKey are definitely very helpful when it comes to sourcing parts. Also, like because we, as a small company, it's not feasible for us to go speak to every vendor out there from all the major companies. So this is, in that way, it helps us like find that one-stop solution. For parts.
In terms of technical difficulty while building this robot and taking to the industry, if you have to point out the most technical challenge that you have faced, what would that be?
Everything has added to that, overall technical challenge. So solving sanding was one major technical challenge. Getting the right localization and odometry stack, that was a very, that was a challenge in itself because Again, like we are not taking any kind of flow plan references, as I had mentioned earlier. Even things as simple as how do you make it IP proof, and such a big structure, because dust and moisture are abundantly present at a site. So even small things like that, and all the way to doing things like sanding, doing a sealing fully autonomously, everything has had its own challenge, which has added up.
Okay, so Ayush, a very interesting piece of equipment that you have here, and I want to dial back and understand how it all started, but let's do that right in your office.
Yeah.
So Ayush, can you tell us from where you started and how you got into this field and how you got into where you are today?
Yeah. So our journey started in 2021. We got incorporated in March.
Okay.
This was when, in fact, at that point, me and Srinivas had been speaking for almost 3 to 6 months. So I come from a robotics background. I did my master's in robotics from University of Pennsylvania, and then before that, I'd done my master's in mechanical engineering from University of Sheffield. I'd spent 4.5 years in robotics R&D in the automotive and agri-tech domain. So before this, I was building robots for the farm sector.
Okay.
And my motivation to look at construction as an industry for robotics came from that background, where I realized that agriculture and construction, they are the largest contributors to the GDP, and they also share a lot of common problems in terms of skilled labor shortage, productivity not going up year on year, and also in general, they're the slowest adopters of anything new.
Okay.
When it comes to technology, automation, etc. So this was my motivation to look at these two industries. But why I then zeroed in, I kind of moved from agriculture to construction, is because construction happens in urban environments. So access to machines is an easy problem. Also, like the appetite of the customer is a little bit more, because they typically are a little bit richer,
Right.
especially in the Indian context. So this was my motivation to start looking at construction. Srinivas, of course, comes from a construction background. He had spent 13.5 years in construction. He had also worked on something called lean construction, which is trying to optimize, trying to bring in the practices of lean to optimize construction.
Understood.
So when we got started, we were speaking about where robotics could fit. The general thought was that robotics has to tackle something which is repetitive, which is mundane, which is boring, and which is also hazardous to health. So when we spoke to customers where robotics could add value, one of the things they mentioned repeatedly was finishing. So finishing in construction includes wall finishing, floor finishing, your mechanical, electrical, plumbing works. But specifically, wall finishing and ceiling finishing is a very labor-intensive task.
Okay.
So if you look at something like sanding, putty application, or painting, it happens over very large areas in construction sites. It's a very repetitive process. And something that we felt, A, it suits robotics very well, and B, for the customer, it drives a lot of value. So this is where we got started. And when we got incorporated, we were also a month or so later, we were incubated at Sign, which is the incubation.
Let's dial back a bit. So you guys decided that you're going to build robots for construction industry, and based on a market survey, you decided that it will be for wall and ceiling finishing. So once you've zeroed in on that, how did you go about with building your very first prototype?
So actually, when we dialed in on finishing, I just want to take one step back. So finishing, even for wall, includes plastering. So this is the thicker coat which is applied to a wall, and then it comes to the finer coats, which are putty, sanding of the putty, which gives you a finished surface, and then finally your primer and painting. So our step one was to look at what is the most advanced in terms of mechanization and automation. So plastering, and when we did a comparison of plastering versus putty, plastering has challenges in material flow, in material pumping.
Okay.
Putty had pumps which were already existing in the market. So at least the spray part of it was by and large solved.
Okay.
We had to come up with a robot which would spray it consistently. And then the main challenge from the robotic standpoint was to develop the sanding solution.
Okay.
And this is where we spent, I would say, in excess of 3 years to get that quality right, to get the productivity right. So yeah, I mean, to start off, we actually built a small prototype which could do only painting.
Okay.
And then started working backwards towards putty spray, and then finally decided.
Understood. So before you took your idea to an investor, you had a working prototype ready. So what all were your checklists before you went to an investor? Like what all were on your mind that my prototype should be able to do this before I take this to an investor? What all were the checklist?
So again, construction is an industry which is very conventional, and the mindset is such that they want to see before they can believe it. And that mindset also then translates to investors. So for us, it was very key that we do, a basic proof of concept that yes, a robot can spray. Yes, a robot can work on a construction site, and it can also eventually one day move towards sanding and plastering, and then also, of course, flooring and ceiling works. So for us, we started with painting, but our goal was to make sure that the painting is done right, the quality comes correct, and also the robot is easy to use, is autonomous in its work, so that eventually our goal of saying that when robotics comes into construction, it doesn't create a new kind of a job requirement. So we are not saying that when you bring robots, you also bring a trained technician. It's the painter, it's the mason who is able to interact and operate the robot. So that was one very key thing that we wanted to prove with our BOC.
Okay. So you have the POC, you took it to investors. Let's talk about how the investors approached your idea in the initial stage. But before that, I want to quickly ask about the initial challenges that you faced when you were building that POC, because robotics involves a lot of elements. It involves mechanical design, it involves electronics, electrical. So when you were building the first robot, what challenges did you face?
I mean, starting off with, we took this approach of building the hardware from the ground up. So we realized that the hardware that exists for industrial robotics may not be the right solution for construction. So the first challenge, of course, came in building the mechanical hardware, and of course the electronics which supports it. The second part was, again, we never wanted the robot to be fed a floor plan for it to be operational. So we wanted the robot to map out its environment, plan its own path within the environment autonomously.
Okay.
So, and also take decisions in terms of obstacles, in terms of areas to be done, and how to do those areas completely dynamically. So that was the challenge on the firmware side. That so I mean, challenges came from SLAM. The challenges came from building the right sensor. I mean, having the right sensor suite and then having the right perception models. So that was the challenge on the firmware side. On the hardware side, of course, it started with something very basic, like getting your mechanical actuators to work properly, your PCBs to be the right way. I mean, not have noise, for example. So there are very basic level challenges that we started with.
Understood. So you have the POC ready and working. You took it to the investor. How was the initial response?
So we have always found more interest from companies or investors who are inclined towards construction and also are part of construction themselves. I mean, general VCs are not someone who have resonated a lot with what we are trying to do here. Because also, I mean, you have to understand, to be able to invest in something, you have to like this. You have to. I mean, it's a long payoff, because it takes time to build the right solution. Construction is also slow in adopting new solutions, so it's a long journey. And typically, we have seen that it's people from the industry who get the idea best, who get the benefits the best. So we always drew attention from people from the industry.
Okay. So how has your investing journey been so far?
So we have been, so far, I would say we have raised capital primarily from Pidlite. So they are one of the primary investors in our company. Other than them, we have also raised a lot of grants from Sign, and they had also given us the initial seed funding. IMA Ventures is another key investor. And also we have of course, MAL 5G is an accelerator who we had, come in our initial days. So yeah, I mean, again, it's tech focused incubation cells and people from corporates from the construction industry who have always given us that interest.
Understood. So, Ayush, once you are back with funding, what was your next step? Like, where did the company focus on next?
So again, like the initial POC only covered painting. So now it was time to go start building the putty solution. So painting is a very, I would say, out of the value chain of plastering, putty, painting, sanding, it is the smallest problem. And in fact, just painting alone doesn't really give the customer a lot of advantage.
Right.
So for the very next step for us was to build a solution that which could at least cover the putty, sanding, and for both wall and ceiling. So this is what we have spent, almost, I would say close to 3 years. And just recently, in fact, 2 months back is when we delivered our first commercial orders.
Okay.
So now we are going to the next step of our journey.
Perfect. So can you talk some numbers, like how many robots has Space Robotics built so far and how much of testing has been done in the real world so far?
Yeah. So we have gone through 4 iterations, entire product iterations.
Okay.
So and I would say all of them were only ended up at the prototype stage, because every time we built something, tested it in lab, took it to the construction site, we realized there were challenges and it was not solving all of the problems that we wanted to solve. So there have been 4 iterations from the R&D standpoint, and now we have, our first 2 commercial orders. First 2 commercial robots have been delivered.
Okay, perfect. So Ayush, as an engineer, you have seen the tech side of it, you have seen the marketing side of it. So which was more difficult, solving the technical problem with the robot or convincing the industry to adapt something new such as robotics? Which was more challenging for you?
I think so far definitely the technical side has been more challenging by far, because construction, although it is slow in adopting something new, they always understood the problem, and they resonate a lot with the labor shortage problem.
Okay.
So we were never ever questioned about the USP of what we were doing. We were never questioned about the advantages of this. It was just about proving that something like this, would it actually work, and would it actually work for large areas? So that was the the bigger concern from the customers. Also, of course, like as a startup, how do you do the maintenance? How do you support with things like your on-site training, support after the sales has been done, software upgrades? If something breaks down, how do you take care of that? So that has been the main concerns from customers, not really that will this help me or not. That has never been a problem. From technical standpoint, because we had, we were trying to build everything from the ground up, and we also had no past examples that we could take inspiration from. That was the hardest part.
When you say there were challenges on the technical side, can you point few stuff which you think these are the things which is not yet solved for the robotics industry?
Yeah. So like if I take the example of sanding, for example, now with sanding, you're trying to, so with spray, we try to apply somewhere between 1.5 mm to 2 mm of putty thickness. And then when sanding, the goal is to achieve a level surface, you're trying to take almost 50% of that off. Now that requires uniform sanding, no matter what the floor conditions are, no matter what the wall conditions are. And in sites, depending on whether tiling has been done or it hasn't been done, screeded floors have been provided or not, if plastering has been done or not, you can see, we have seen gaps up to even 13 mm, 14 mm from one end of a wall to the other end. So how do you give, some millimeter level uniformity over this kind of variation? That was the main challenge. How do you then, of course, if you're not going to go with a floor plan, how do you, localize and plan your path with millimeter level precision? That was the challenge for us.
Okay. So Ayush, after 4 iterations of testing your robot inside a lab environment, you took it to the construction industry. So how did it perform in the very first trial? And like, what are the differences that you see when a robot works in a lab setup versus actually in the construction site?
Yeah. So in lab setup, we have something called as drywall gypsum boards, which are perfectly leveled. And then we also have a perfectly leveled floor. We never have any electrical issues such as voltage fluctuations.
Right.
We don't see dust. We don't see people just randomly moving about. We don't see random obstacles flying around. So construction site is a complete new beast compared to compared to the lab. And to be honest, every time we have taken a new prototype to the site, the first month has been chaos because everything that we thought would go wrong went wrong every single time. So yeah, I mean, in short, I don't think there has been a single deployment where everything worked perfectly.
Understood. So, what is your way forward? Like these robots, how long has it been tested in the construction site? Like, what are your testing numbers so far?
Yeah, I mean, cumulatively, I think we would have done in excess of, I would say, 2 years of continuous testing. That would translate to, I mean, I would say, I have to check the numbers, but it would be somewhere close to 1 million square feet of testing. I mean, this is across, of course, our own lab facility and then the various sites we have done pilots at. So, yeah, I mean, just in pure testing, we have spent a lot of time in a lot of area. And yeah.
Okay, so where do we move from here? What is the next step for Pace Robotics?
So the next step for us is that we have gone commercial with putty, sanding and painting for both wall and ceiling. Now I mean, we are also trying to kind of come up with a solution for plastering. And also come up with a solution for concrete grinding. This is something that we plan to do in the next 1.5 years. And then post that, we also want to look at the flooring solution.
Perfect. So, as you mentioned, you have already gone commercial with this putting and painting robots. So, when you say it's commercial, what is the business model here? Do people purchase the robot, or is it some kind of service that's being offered? How do you work as a business?
So as of right now, we are selling the robots directly. And that is the plan now for at least the next couple of years, at least. Lease is something that we can potentially look at. I mean, when we also grow as a company, but that is not something immediately in plan. So direct sales is something that is happening right now.
Perfect. So Ayush, I think your experience with robotics has been very fresh. The last 6 years should have been a lot of growth for you. For people who are interested in robotics, who want to work in robotics or start something new with robotics, what would be your word of advice?
So two things. One is, of course, robotics, as you mentioned, is combination of multiple domains. So it covers mechanical engineering, electronics, electrical, and then of course a large part of computer sciences, so your AI, computer vision, etc., etc. So I mean, of course, you cannot be a domain expert in everything, but as a robotics engineer, you should be interested in knowing at least the fundamentals of as many of these domains as you can. And being strong on fundamentals really helps because a lot of the higher level stuff ultimately always comes back to fundamentals. So my recommendation would be always, I mean, one, having a very key interest in understanding the basics, and then of course being always ready to fail, to try things out, because I mean, a lot of things come through iterations. I mean, in my experience, there hasn't been a single thing I've tried the first time and it's gone right. So just
if you have to point out some tech stacks, I think you mentioned SLAM sometimes back as one of the difficulties. If you want to mention some of the tech stacks or things or verticals that people should learn about, what do you mention?
So of course, with it starts on the mechanical side. It starts with basic kinematics and dynamics, and then your finite element analysis, things like that. For us, of course, also CFD plays a big role and fluids plays a big role because we are in the job of spraying. When I come to electronics, it's your basic transistors, MOSFETs, op amps, things like that. So your passive and active electronics. Microcontrollers, processors, understanding how they work, your OS systems, and then when it comes to the intelligence side of things, it starts with, of course, your basics of SLAM, your path planning, control systems, and then on the computer vision side, I mean, it starts again, it would always start with the fundamentals, like your your basic things, like your being able to take a photo and being able to to apply filters to get your edges and areas of interest out. And then, of course, it then gradually moves on to your neural networks, CNNs, and transformer models and things like that.
Understood. So I'm done with most of my questions here. Is there anything in specific that you would like to add on to this?
I think I have also covered most of
Okay, then thank you so much, Ayush. I think it was a really insightful discussion. Thank you so much for your time.
Thanks a lot. Thank you.